Bismillahirrahmanirrahim. Now we have the actual questions on this permutations and combinations. So far, we have been just warming up for these actual questions of this topic. Okay? So the first question says, find how many 5-digit numbers can be made using the digits once each if there are no restrictions. So we have 5 digits with us and we have to make 5-digit numbers. So this is going to be the first part's answer is simply going to be 5 factorial. Okay. Um, Now, there is a question here you must be asking. It says, find how many 5-digit numbers which can be made using these digits once. So that means we are not going to do any repetition. Now, suppose if the repetition was allowed, then how many 5-digit numbers we can have? Yes. And you have to respond quickly because I'm recording it. Please be quick if you have any idea. If you are allowed to repeat, you're allowed to reuse a digit, then how many 5-digit numbers we can have? Yes. Anyone? Isha Kamran?
Sir, 5 raised to power 5.
Exactly, Isha. Now, when Isha says that if the repetition is allowed, the numbers, 5-digit numbers would be 5 raised to power 5. Is that clear to all of you? Is there anyone who's
No,
not
sir.
clear? Hmm?
No, sir.
Okay, let me
No,
explain.
sir.
Let me explain to you better. Now, this is 5 factorial because you see, when you are not allowed to repeat, because we started by through the questions, okay, we're going to interview 10 people. So how many ways we can interview those 10 people? So that was 10 factorial, because for the first person to be interviewed you had 10 options. Okay, and then when one person has been interviewed, then you had 9 options. So that is why it was 10 into 9 into 8 and so on. So that was going to be 10 factorial. When you're not allowed to repeat them, so you see that you will have 5 options here. Now, for example, one of them, for let's say 4 has been used here. Now, how many options, how many numbers, digits left? There are 4. Then you have 3, then you have 2, and then you have 1. So this is exactly what we say, which is called 5 factorial. But suppose if you were allowed to repeat, you were allowed to repeat. Okay. Now see what kind of the situation you will have. Look at this. For the first place over here, you have 5 options. Suppose 4 was used here. Can I use this 4 again?
Yes, sir.
Yes. So I'll again have 5 options here. I will again have 5 options here, 5 here, 5 here. So that is why the total number of 5-digit numbers is going to be 5 raised to power 5. 5 raised to power 5. Now this should be clear. This should be clear to you if I have to proceed.
Yes, sir, it is. Thank you.
Okay. Okay. Now suppose if using these 5 digits over here, I want to make a 3-digit number. I want to make a 3-digit number. How many numbers I can make now? Yes. From these 5 digits, I'm going to use 3 of them. So how many 3-digit numbers I can have? Yes.
5p3 into 3
The
factorial.
5, 3.
It is 5p3. It is simply 5p3. Or this is 5c3 times 3 factorial. Because now you will be excluding this part. You have only 3 slots, okay? So for the first slot, you have 5, then you have 4, and then you have 3. So you can directly find it through 5p3, okay? Or you can do it 5c3 times 3 factorial. Okay? Now, suppose if you were allowed to repeat the digits and you want to make a three-digit number, how many numbers are possible now?
5 raised to power 3.
Exactly. That will be 5 raised to power 3 because you don't need to have these two digits over here. Okay. So that would be then 5 raised to power 3. I believe you guys are understanding this. Okay. So if you people must feel freedom here, total freedom here to ask at any stage. You can interrupt. Okay. So that is for sure available to all of you. This facility, this freedom, this service, whatever this. Okay. Now moving on to the B part. It says the 5-digit number must be odd. The 5-digit number must be odd. Now, there is a restriction over here. Now, it says the 5-digit number must be odd. You see, now there is a condition on this last digit over here. We can have anything over here, but you see, when there is an odd number, the units digit has to be an odd one. So how many odd digits do we have here? This is 2. So these are two odd digits over here. Okay, so you can have either 3 or a 5 over here. So you will have 2p1 over here. Remember, 2p1 or 2c1 mean the same. Like choosing one from two or then arranging it, it is same. So 2p1 or 2c1, you can write whatever you want. Okay. So now, when you can have either 3 or a 5 over here. So any one of those two digits has been fixed here. How many digits we are left with now?
Answer 4.
4. So you can write here 4p4 or you can write 4 factorial. So that is 4 factorial times 2p1. Okay? Okay, there is no like the silence means that it is clear. Like I'll take your silence as the license to go ahead. Okay. Now, suppose if you were allowed to repeat, okay, we were allowed to repeat, then how many odd 5-digit numbers we can have? Hmm?
So 2p1 into 5 raised to the power 4.
It is 5 raised to power 4 times 2p1 kar lo ya 2 kar lo, it's the same, okay? Times 2 or 2p1, your answer is absolutely right. Because 2p1 is 2. I'm writing 2 because I have two options here, okay? So 5 raised to power 4 times 2. This is the number of odd 5-digit numbers if we were allowed to repeat the digits. Okay. Next is the 5-digit number must be even. The 5-digit number must be even. Okay. The 5-digit number must be even. So one way is simply, you see this was 5 factorial was a total and these are the odd numbers available to you. This is 2p1. So if you subtract the odd numbers from the total numbers, you will be left with the even numbers. You will be left with the even numbers. Or if you want to find this directly, then you will have to write here 3p1. Okay? Because there are 3 even digits over here. Any one of these 3 can be fixed here. And then you are left with 4 digits. So please check from your calculators. Do you have the same answers? You find this and then you find 4 factorial into 3p1. We must have the same answers for these.
Yes, sir, it's the same.
It's the
72.
same. And is it clear to you as well?
Yes.
Okay, okay. Now we are going to move to the third part. Oh, now there are restrictions on both the beginning of this shape block, whatever, and towards the end. It says odd and less than 40,000. Odd and less than 40,000. Now, this is a bit harder question. Let me make an easier example first, and then maybe we can try this part. Okay. Now, suppose the question is, let's say the question is, we want to have uh, he has made a big jump over here by asking this question. Now, suppose we have these digits 2, 3, 4, 5, and 6. Now, the question is that you want to have uh, 5-digit numbers, okay? 5-digit numbers which are more than, let's say, 30,000. चलिए 40,000 कर लेते हैं, which are more than, greater than 40,000. Okay, so is there any condition towards this unit side over here? Is there any condition over here?
No, sir.
We only have the condition here if it says okay, it has to be odd, it has to be even, it has to be a multiple of 5, it has to be a multiple of 10, blah, blah, blah. Okay, so there is no condition over here. We are free that we can have anything at the very end of this number, but there are some restrictions over here. The number we want to have, it should be more than 40,000. So can I have 2 over here?
Yes, sir.
Can I have 2 here?
So it's
Oh,
more
sir.
than the
Sorry,
six.
We can
Will
you
have
have.
2 over here, okay? So since we need to have the numbers more than 40,000. So we have the options here. We can have 4, 5, or 6 over here. Okay, so this is going to be 3p1 times 4 factorial. 3p1 times 4 factorial. Do you get this?
Yes, sir.
Okay, बच्चों फिर मैं बता रहा हूँ खुदा की कसम, मुझे फिर क़यामत वाले दिन ये ना कहना कि सर ने मैं परम्यूटेशन कॉम्बिनेशन नहीं सही पढ़ाई थी. मैं बता रहा हूँ, you people are responsible for this. Okay,
Sir,
and
I
you,
have a question.
yeah.
Sir, if like I haven't been using the 3p1 formula, I just like list out like the two options. Like either it can be for the third part, I did like either it could be 2 or it could be 3, and then I just added them up like 3 factorial into 2. If we do it that way, is it fine?
Uh, this is totally up to you, beta. Let me share something over here. We were having a maths workshop with the people from Cambridge, and there was a question like this, and there were 4 marks for this. There are 4 marks for this. And we were like criticizing, like there was a session where we had to criticize the marking scheme or whatever, like whatever objections we had. So this was a main criticism on this question, that why do we have so many marks for this? And that person, the what do we call that, the ones the examiner from the UK, he told us that look, some of the students can give this answer as one liner, but there will be students who will be covering the whole page, maybe more than that, for the solution of this. Okay. Um, so I was telling you that there can be people who can cover 2, 3, 4, 5 pages on answering this. Maybe like, who was this? I think that was Satish. She was suggesting that you
Yes.
list all of them.
It didn't take 2 or 3 pages. I just like made 2 combinations and then I added up the
Okay,
probability. That's
but the choice is all yours. The choice is all yours. I'm not going to pressurize you, force you that, no, you have to use my method. Okay. So, beta, the thing is how you perceive it. You must go for the method that is easier for you. Okay. So, choice is all yours, beta. Achha, so this is going to be 3p1 times 4 factorial. Now, let me add some red chilies into this question. Suppose the question is, you have to make a 5-digit number which is greater than 40,000, and it should be odd as well, and it should be odd. So what will you do now?
Sir, 2p1 into 3p1 into 3 factorial.
Okay, that's it.
सर बेसिकली सिंस एक बार यूज़ कर सकते हैं खाली अगर एंड पे एक नंबर फिक्स हो जाए दैट कांट बी यूज्ड इन द बिगिनिंग सो डोंट वी हैव टू मेक मल्टीपल केसेस देन
Yeah, there now you will have multiple cases because good. Look at this. You have here now when it says odd and greater than 40,000. Now the thing is, we can have 4, 5, 6 here, and we can have 3 and 5 here. Okay, we can have 4, 5, 6, and then 3 and 5. So now to make this working simpler, we are going to fix first 3 because there are only 2 options. Okay, so if I fix 3 here at the very end, let me okay, if I fix 3 here, okay, then I have clearly 3 options like, 4, 5, and 6. Any one of them can come here. It will still be an odd number. So this is going to be 3p1. This is going to be 1p1. And then there were 5 digits. 2 have been used. So there are 3 slots here. So this is going to be 3p3, or you can write it as 3 factorial plus, then you will fix 5 here. Okay, when you fix 5 here, then you only have 2 options left over here because 5 has to make it an odd number. So we have fixed 5 here and we have these 2 options left here. So this will be now 2p1 into this 1p1, and then you have 3p3. You add these two, that will be the number of 5-digit numbers which are greater than 40,000, and they are odd. And they are odd. Okay. If it's clear, then I can move on to 1b3.
Sir, can you explain कि जिस सताइश ने कहा था कि in the end it's going to be 2p1 वो गलत क्यों है?
I will not tell you because that is Stice method. You ask me about this if this is clear to you or not, because there are 100 ways of doing it. I can explain all those 100 methods. I'm really sorry for that. I can't.
Sir,
And
this is clear.
okay,
This is clear. Thank
thank
you.
you, thank you, Veda. Okay, now let's go on to 1b3, odd and less than 40,000. Okay. Now remember, in the very beginning, like this statement, you must know that this statement is for all these parts over here. So he is asking here for the 5-digit numbers. Okay, I'll first do what he's saying and then I'll change the statement. Okay, now we need 5-digit numbers which are odd and less than 40,000. Now, if the numbers are less than 40,000, what can be kept here at this 10,000 place?
So 2 or 3.
2 and 3. Okay, I think you should try it now yourself. You can have 2 and 3 over here. You can have 3 and 5 over here. Please try it yourself. Okay, who would like to share her answer? What was her actual way of doing it? Yes,
सर मैं
yes, please, please. Yeah.
ओके सो सर फिर आई फिक्स्ड 3 लास्ट प्लेस के अंदर
Okay,
सो
you fix 3 here. Yeah.
जी and that means कि first place के अंदर we only have 2 as an option because 3
Very
has
good,
already been
Bata. That's great. That's a great thing to do. Okay, let me pause for a minute. There is continue. Yes. So you fix 2 here, you fix 3 here. That is quite reasonable thing to do. Okay. and then you only have 3 factorial. You see, there is no need to write 1p1 or 1 factorial because there is always 1. So filhal, this is going to be 3 factorial plus. Then what you did, beta?
उसके बाद सर सेकंड केस के अंदर फिक्स्ड 5 एट द एंड, दैट मींस के फर्स्ट ब्लॉक के अंदर दो ऑप्शंस हो जाती हैं 2 and 3 both.
Very good. You are playing great. Okay. So you fixed 5 here. And now you have two options. You can have either 2 or 3 over here because you want to have a number which is less than 40,000. Okay. So now you have 2p1 times, there is 3 factorial or 3p3. That means the same. And then this is 1p1. Okay. There's just 5 is fixed here. And there are two options. So that is why you have 2p1 times 3p3. Okay. So you add them together. This will give you the number of the numbers, 5-digit numbers, which are less than 40,000. And they are all odd. Is there any question, Bacho?
Sir, I did it slightly differently. I fixed my values in the first block first, but I have the same answer.
Perfectly all right. Perfectly all right, beta. Perfectly all right. No problem with that. Okay, now, if you were in the school and the canteen was open, then I could have asked you a question for a biryani. Okay. Now, the question for the biryani is, believe me, this is a question, and you can find this in your past papers. Now, there is no condition for here to be 5-digit or 3-digit or 4-digit. Now, the question is, now I'm going to rephrase. The question is, find how many, I'm just going to cut it out, okay? Find how many numbers can be made using the digit blah, 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 which are odd and less than 40,000. Please do this now. We have to find the uh, number of the numbers using all these digits just once, and the number should be odd and less than 40,000.
Once?
Yes, once. Now, since we are running out of time, so I will explain this to you. You see, the thing is that when it says less than 40,000, so you must consider all the cases where these numbers can simply be 5-digit. They can be 4-digit. They can be 3-digit. Okay. They can be 2-digit, and they can even be 1-digit number. So that is the complicated or the hidden thing in it. When students answer this, they answer this wrong because they don't consider all these situations. Okay. So when you have to have the numbers which are less than 40,000, so less than 40,000 means it can be 5-digit. All these possibilities are there. So we have already got the 5-digit numbers is ready with us. Okay, we have just discussed this because that was 1B3 as it is. Now when it says 4-digit numbers, bacho, so 4-digit means now you have to focus on to this part. There is no condition over here because if it is going to be 4-digit and it has to be less than 40,000, so anything can be here at the 1,000th place. Okay, now these are 4-digit over here. So what can we have over here? We can have 3 or 5 here. There is only condition onto the very end of this. So this is going to be 2p1. And what would be for this, for these 3 blocks? Yes. How many digits do we have available right now?
4,
4. And how many do we need?
3 तो
Three.
सर 4 3 हो जाएगी.
So this would be
4p3.
4p3. Okay. Now when it says 3-digit number, okay. So 3-digit number. So that means again, it has to be odd. So 3 or 5 can come here. Okay. So yes, this is going to be 2p1 times. How many slots we need to fill in? Yes.
2.
And how many digits do we have?
4.
4. So this is going to be 4p2. And for the 2-digit numbers, bacho, You see again, you have two options for this. It can be 3 or it can be 5. And we still have this empty block over here. So this is going to be 4p1 times 2p1. And it has, if it has to be single digit number, so this is going to be 2p1. So you add all of them, that will be the answer to this question, that if you want to have odd and less than 40,000, keeping in mind that the number can be a 5-digit number, a 4-digit number, 3-digit number, 2-digit, and even a 1-digit, single-digit number. Now, is that clear to you? Is that clear?
Yes,
Yes?
sir.
Yes, sir, it is.
Okay, this really sounds great. Okay, please try this third question, question number 3. And try this quickly. We just have 3 minutes for this session. 3 minutes left for the session. Okay, the easier way of handling this question is, first of all, you find the total, what is the total number of 6-digit numbers? So that would simply be 6 factorial, because there are 6 digits, that is going to be 6 factorial. Now let's find the 6-digit numbers which are odd, okay? So that means you have a condition here at the very end over here. So how many odd digits do we have here? We have 7, 5, 3, and 1, okay? So there are 4 possibilities. So this would be 4p1. And now, how many slots we have to fill in?
Sir, 5, so it'll be
And how many digits
65.
are available? 5. So that is going to be 5 factorial or 5p5, okay? So this is your odd numbers, which are 5 factorial times 4p1. And for the even numbers, you simply subtract these from 6 factorial, okay? 5 times 4. Okay, since it's asking for the ratio, let us just find the even numbers. That will not take so long. So for the even, you have how many options here? 2. This 2p1, and this is going to be 5 factorial. Let's find that, odd to even. So this is odd.
So it'll be 2.
2
Yeah,
ratio 1.
yeah. So that is going to be, there is 5 factorial times 4p1, ratio 5 factorial times 2p1. So we can cancel out the 5 factorial with the 5 factorial. Yes, okay. And then you can, 4p1 is going to be 4. Yes. And 2p1
Yes, sir. Perfect.
2. So your answer is going to be 2 ratio 1. I think that's easier way to handle this. Okay. Now we're going to end this session here, and let's try some harder questions in the next session. Thank you very much.